classification, regression, linear regression, non-linear regression, and logistic regression. Okay. Now, what is meant by statistics? See, statistics is the science concerned with being collecting the data for analyzing the data. That means numerical data we are comparing with the existing versus proposed system. So statistics can be used to derive meaningful insights from data by performing mathematical computations on it. In analysis, we have two types: quantitative analysis and qualitative analysis. Quantitative analysis says that the size of the matter is very less, and the quality of the matter is very less, and the quantity is very high. Whereas qualitative data, the meaningful data is very high, and the size of data is very less. So that analysis we are doing with help of statistical techniques. You see, introduction to statistics, what I am going to explain today. What is statistics? It is a branch of mathematics that deals with the collection of data, analysis of data, interpretation of the data, and the presentation of the data. In data science, statistics is a critical component because it provides a framework for understanding and making decisions based on data. So we have two types of data: quantitative data and qualitative data. So what about the statistical techniques? So statistical techniques such as regression analysis, hypothesis testing, and machine learning algorithms are widely used in data science to identify patterns and relationships in data, make predictions and classification, and inform decision making. Why do I want to use statistical techniques? In order to predict the data, in order to classify the data, in order to extract meaningful data, we are using statistical techniques. Then statistics is an essential tool in providing the methodology for analyzing data and extracting meaningful insights that can inform business decisions, improve products, services, and drive innovation. So Sundar, now you are seeing the slide number 335.
34.
Yes, sir.
34, still not loaded yet.
Yeah, so in the statistical methods, we are classifying into two types, and descriptive methods and inferential methods. Under descriptive methods, we have three types: univariate methods, bivariate methods, and multivariate methods. Univariate is nothing but only one variable is there, and we are performing the regression concept like shape, center, spread, relative position. By having two,
just
one
now
or
I
more
got a
means
335.
two variables. Yeah. But my voice is clear.
Oh, your voice.
My voice is clear.
Go ahead.
Okay. So under statistical methods, we are dividing into two groups like descriptive methods and inferential methods. So univariate means single variable. We are performing all the operations of descriptive methods. Under bivariate, we have two variables, and we are performing like a correlation and regression. You need to have x1, x2, y1, y2, etc. Then multivariate means we have more than two, like multiple regression. Then coming to inferential methods, we have a central limit theorem, binomial theorem, hypothesis significance testing, normal distribution applied to means like a t-test and ANOVA, etc. these are the two types of data we are discussing under statistical methods: qualitative data, quantitative data. If you see qualitative data, maybe categorical data and attribute of the data. That refers only to name classifications. Qualitative examples: marital status, political party, eye color, defined categories. Then quantitative data, nothing but numerical data is also called as a quantitative data. Data that represents counts or measures, etc. We are classifying into two types, like a discrete uh, quantitative data, continuous quantitative data. Discrete quantitative data is nothing but counted items, examples, number of children in a family, defects per hour in a software. Then continuous measured characteristics, examples like weight and voltage. Next, coming to the more advanced probability and statistics, you can see central tendency. So we have statistical operations like mean, median, mode, outliers, etc. So measure of spread is nothing but it is one more concept in statistics. It describes range, standard deviation, variance, and quartiles. And percentiles, like position of a data, percentile rank, percentile range. Then probability distributions, uniform, normal, Gaussian, Poisson distribution. So then coming to the basic probability and statistics. Then dimensionality reduction, pruning and PCE. So these are the two techniques like principal component analysis and regression. Then sampling is one of the concepts in Python. We are preparing SRS, reservoirs, undersampling, oversampling, etc. Then Bayesian statistics, measuring belief or confidence by using this formula. P of A by B equal to P of B by A multiplied by P of E divided by P of B. Then you can see covariance and correlation matrix, how data is related. Then see what are the examples of statistics. There are many examples of statistics. The average height of a group of a people. Then the percentage of voters who support a particular potential candidate. The median income of particular city. I have underlined this red color, indicates the operations of the statistics. The standard deviation of a set of test scores, the median income of a particular city, the standard deviation of a set of test scores, the correlation coefficient between two variables such as age and income, the probability of a particular event occurring such as rolling a 6 on a dice. The frequency distribution of a set of data, such as the number of times each letter appears in a given text. This experiment we are performing on forthcoming days. And you can see the confidence interval, a particular measurement such as the margin of error in a political poll. If you see the coefficient of determination in a regression analysis, which measures how well a line of best fit predicts data points. And the t-test or ANOVA test, analysis of variance, which are statistical tests used to determine whether there are significant differences between, you can call it as a significant differences between or more groups or sets. So these are the standard formulas we are using in order to perform a map reduce concept. Mean x bar equal to sigma x bar by n. So mean x bar equal to sigma xi by n, and variance sigma of xi minus x bar whole square by n. Then median n plus 1th of term when n is even. Then nth power 2 term plus n by 2 plus 1 by class lo unna yena nammal chestanu class lo half an hour. So where n is the even number,
Sir,
mode equal to the value in that.
Doctor, if you have some private call, yeah, please feel free to take it. I can wait.
It's okay, no problem. I told them.
Doctor, if you want.
So mode is nothing but see, these are the. No, after this class I can talk. That is Indian timing, no problem.
Okay.
So these are the statistical operations like mode, mean, variance, mid. The value in the data set that occurs most frequently. I am going to demonstrate these formulas in the while performing applications. Statistics for data science, if you see, statistics is used to process complex problems in real world so that data scientists and analysts can look for meaningful trends and changes in data. Statistics can be used to derive meaningful insights from data by performing mathematical computations on it. Then basic statistics formulas like population measures, we are using formulas. For sampling, we are using formulas. And for linear regression, we are using formula. And probability, we are using formula. And one sample jet statistics, one sample T statistic, and two sample T statistics. These are the core Python, core statistical basic formulas and sample proportions.
What is called one
like,
sample T statistics? What is called two sample T statistic?
Yeah, sir. Because, yeah, very good. Single variable we are taking as input value and performing the operation. That is called one sample T statistics. If you are taking two variables as input and we are like x1, x2, y1, y2 like that if you are taking and we are performing two sample T statistics. Like x, that is called one sample T statistics. Or if you are taking two samples like x1, x2, y1, y2, like that is called two sample statistics. Sample proportion, we are using like a sample size to test H naught and like two sample proportions and the size square statistics and central limit theorem. So based on our results, we are comparing with the size square test whether this model is correct fit or not. We need to justify. Next, coming to third concept, concepts of statistics. What are the major concepts we are studying under statistics? Like descriptive statistics, inferential statistics. Descriptive statistics called, this involves summarizing and a final conclusion and describing data using measures such as mean, median, mode, standard deviation, and range. Inferential statistics, this involves drawing conclusions or making predictions about a population based on a sample of data. Then a third one, probability. This is the study of random events and their likelihood of occurrence. Then hypothesis testing. This involves testing a hypothesis or claim about a population using a sample of data. Then you can call it as a hypothesis testing. This involves testing a hypothesis or a claim about a popular using its sample and sample data. Sampling, this involves testing a hypothesis or claim about a population using sample of data. Then you can take it as a sampling. This involves selecting a representative subset of a population to collect data from. And correlation. This measures the strength and direction of the relationship between you can call it as a statistical significance. See, correlation means we are measuring the strength and the direction of the relationship between two variables like x1, x2, y1, y2. You can do many things. And the regression, this involves modeling the relationship between one or more independent variables and a deployment. You can call it as my voice is audible, Sundar.
Yes, yes. I think in between it breaks, but it's okay.
Yeah, confidence intervals is nothing but these are ranges of values that are likely to contain the true population parameter. Statistical significance means this is a measure of the likelihood that a result is not due to chance. Then what about experimental design? This involves designing and conducting experiments to test hypotheses and draw conclusions about the population. So next is there are 8 statistics concepts becoming a data scientist. What are the 8 concepts? Understand the type of analytic, probability, central limit theorem, variability, relationship between variables, probability distribution, hypothesis testing, and statistical significance, regression. To understand the type of analytics, descriptive analysis is nothing but it tells us what happened in the past and helps a business understand how it is performing by providing context to help stakeholders. That is interpret information. That is called a descriptive analysis. Then you can call it as a predictive analytics and a prescriptive analytics. Predictive analytics, it predicts what is most likely to happen in the future and provides companies with actionable insights based on the information. Perspective analysis provides recommendations regarding actions that will take advantage of the predictions and guide the possible actions towards a solution. And probability. Probability is the measure of the likelihood that an event will occur. Madam Sundar, 2 minutes, Sundar.
Sure, sure.
Yeah, 1 second. Leaving. Madam, thank you, madam. Yes. Yeah, sure, madam. Anytime, madam. Yes, yes. Yes, 12 months. I think all US students are getting off. Thank you. Yeah. So Sundar, now I'm starting probability. So probability is the measure of the likelihood that an event will occur in a random experiment. We are performing operations like a complement, intersection, and union. So P of A plus P of A dash equal to 1, that is called complement. Intersection means P of A intersection B equal to P of A multiplied by the P of B. Then union, it is combining P of A union B equal to P of A plus P of B minus P of A intersection B. So that is called the first figure shows the intersection portion and second figure shows that the union of A and B circles. And what is meant by conditional probability? P of A by B is a measure of the probability of one event occurring with some relationship to one or more other events, like P of A by B equal to P of A intersection B by P of B, when P of B greater than 0. Then B independent events, like two events are independent if the occurrence of one does not affect the probability of occurrence of the other. So if you take example P of A intersection B, P of A multiplied by the P of B, where P of A not equal to 0 and P of B not equal to 0. That means P of A by B equal to P of A, comma, P of B by A equal to P of B. That is called independent events. Then next concept is mutually exclusive events. Two events are mutually exclusive if they cannot both occur at the same time. That is called P of A intersection B equal to 0 and P of A union B equal to P of A plus P of B. Then what is my Bayes theorem? Bayes theorem describes the probability of an event based on prior knowledge of conditions that might be related to the event. So P of A by B equal to, that is called posterior probability, P of A by B divided by P of B equal to P of A multiplied by P of B by A divided by P of B. So prior probability, the red mark indicates prior probability, where A and B are events and P of B not equal to 0. This is called Bayes theorem. In order to predict the future values, we are using Bayes theorem. Then the third concept is a central tendency. What is meant by central tendency? So central tendency is nothing but we are calculating the operations like mean, median, mode, skewness, kurtosis. That becomes as a central tendency. Mean is nothing but the average of the data set. Median is nothing but the middle value of an ordered data set. Mode is nothing but the most frequent value in the data set. If the data have multiple values that occurred the most frequently, we have a multimodal distribution. Then the skewness, a measure of symmetry, that is called skewness. And kurtosis is nothing but a measure of whether the data are heavy tailed or light tailed relative to a normal distribution. If you see the skewness, so if you see the skewness, so we are calculating positive skew and negative skew based on the mean, mode, and median. We are deciding the which value comes under positive skew, which value comes under negative skew. That is called kurtosis. That is called skewness. Then what about kurtosis? Kurtosis is nothing but a measure of whether the data are heavy-tailed or light-tailed relative to normal distribution. So yes, kurtosis greater than 0, that is called, you can call it as leptokurtotic. Then equal to 0, you can call it as a mesokurtic. Then yes, kurtosis less than 0, we can call it as kurtosis. Then the fourth concept is variability. So variability is nothing but varying value at runtime duration. So there we are performing range and percentile, quartiles and interquartiles. We are performing the operations. Range is nothing but the difference between the highest and the lowest value in the data set. Then what about percentile, quartile and the interquartile range? That is called IQR. Percentile is nothing but a measure that indicates the value below, which is a given percentage of observations in a group of observations false. Quantiles is nothing but values that divide the number of data points into 4 more or less equal parts or quarters, etc. Interquartile range, a measure of statistical dispersion and variability based on dividing a data set into quartiles, that is called IQR, equal to Q3 minus Q1. See the figure, you can come to know where we are using a percentile and quantiles.
So,
And the
Doctor,
yeah,
why there is
yeah,
not
please tell.
why there is no Q4? Q4 is,
Yeah,
let's say, we're going to divide that data points into 4, Q1, Q2, Q3. There's supposed to
yes,
be Q4, correct?
yes. But Q4, why? We are taking as a Q4 place IQR, we are taking as a variable. If you see, so outlier which is not falling into the data that
Yeah.
behaves abnormal,
Yes.
that is called outlier.
Yes.
And the minimum value, maximum value, yeah, minimum value and maximum value between, we are finding the difference, that is called range. And from minimum to quartile 1.
So
And
the
maximum
range
to
is max minus min, right? That's min
correct,
and
correct,
max. Yeah, that's a range.
correct, correct.
Okay.
Then yeah, percentile we are taking as Q1 and Q2 and Q3. Here Q2 acting as a median because it's a middle point.
Okay.
And yeah, that Q4, whatever the doubt you have raised, the correct answer. Instead of Q4, we are using as a IQR. IQR is nothing but Q3 minus Q1. It indicates the difference between quartile 1 minus quartile 3. That means from quartile 3 minus quartile 1 is called IQR. That is called interquartile range. Very good question, Sundar. Keep it up. Then we are moving to variance. Variance is the nothing but the average squared difference of the values from the mean to measure how spread out a set of data is relative to mean. Then D, standard deviation. The standard deviation is nothing but the difference between each data point and the mean and the square root of variance. So if you want to calculate the population, sample and the variance of the population, standard deviation of the population. Sigma square equal to sigma of xi minus mu whole square by n. N is nothing but number of samples. Then standard deviation we used to represent sigma equal to square root of sigma xi minus mu whole square by n. Then the same case sample, in order to calculate standard deviation, for a variance s square equal to sigma of xi minus x bar whole square by n minus 1. S is equal to square root of sigma of xi minus x bar whole square divided by n minus 1. So these are the population sample variance and standard deviation. Then standard error, an estimate of the standard deviation of the sampling distribution is called standard error. So why do we want to perform standard error? While performing any project or a research article or any application, if you are decreasing the size of the error, means automatically you are increasing the accuracy. That is the reason we are performing standard error. So the formulas for standard error for population, standard error is sigma x bar equal to sigma by square root of n. For estimation, we are using formula sigma x bar related to s by square root of n. For sample, we are calculating standard error is s x bar equal to s by square root of n. That means it is for population and as well as a standard error. Next, fifth concept is relationship between two variables. So relationship between two variables, so whether it is positive relationship or negative relationship or no relationships, it is done with the help of causality, covariance, correlation. So what is meant by causality? Relationship between two events where one event is affected by the other. Covariance is nothing but a quantitative measure of the joint variability between two or more. The normalized version of covariance. Measure the relationship between two R variables and range from -1 to 1. The normalized version of covariance, see here formula. So covariance formula is COV of x comma y 1 by n multiplied by sigma I is equal to 1 to n of xi minus x bar multiplied by yi minus y bar. That gives then correlation, that is covariance. Correlation of x comma y equal to CO. Correlation of x comma y by square root of variance of x and variance of y. Then correlation formula, we are having positive relationships, negative relationships, and no relationships. And sixth concept is probability distribution. Why do I want to perform probability distribution? So there are three approaches we are using. So a function PMF is nothing but probability mass function, a function that gives the probability that a discrete random variable is exactly equal to some value. Probability density function, a function for continuous data where the value at any given sample can be interpreted as providing a relative likelihood that the value of the random variable. Then cumulative density function. So a function that gives the probability that a random variable is less than or equal to certain value. If you see the diagram, you come to know what are the three methods we are using. Probability distribution, like discrete and continuous, PMF, probability mass function, PDF, probability density function, CDF, cumulative density. Then we have very good techniques like PMF, PDF, and CDF comparison between the remaining three models. Then continuous probability function, uniform distribution, normal or Uniform distribution, also called a rectangular distribution, is a probability distribution where all outcomes are equally likely. Normal or Gaussian distribution. So the curve of the distribution of a bell shape and symmetrical and is related to central limit theorem. Central limit theorem that the sampling distribution of the sample means approaches a normal distribution as the sample size gets larger. See the uniform distribution, how it look like 0 to x, a and b are the variables. Then f of x is equal to 1 by b minus a. Then second example is we are calculating Gaussian method or normal distribution. The curve of the distribution is a bell shape and symmetrical and is related to the central limit. So that can be sampling distribution of the sample means approaches a normal distribution at the sample size gets larger. Exponential distribution, a probability distribution of the time between the events in a Poisson point process. That is called exponential distribution. Chi-square distribution is nothing but the distribution of the sum of squared standard normal deviations. Exponential distribution and the chi-square distribution. So you can see the chi-square distribution, the distribution of the sum of squared standard normal deviations. If you see the figure, exponential distributes, it starts with probability density. Then a chi-square distribution, it is a slight difference between Bangalore and Gujarat. So these are the next discrete probability distribution. There are three methods like Bernoulli distribution, binomial distribution, and the Poisson distribution. This is discrete probability distribution like 3, Bernoulli's distribution, binomial distribution, Poisson distribution. What is meant by Bernoulli distribution? The distribution of a random variable which takes a single trial and only two possible outs, namely with the probability p and with the probability 1p. Then binomial distribution we have studied in mathematics, inter and pre-university. The distribution of the number of success in a sequence of n independent experiments, and each with only two possible outcomes, namely, I guess, with the probability Poisson distribution and the binomial distributions are very important for predicting the future values. So the distribution that expresses the probability of a given number of events k occurring in fixed interval of time. If these events occur with the unknown and contest average rate and lambda and independency of the time. These are the examples. If you see right side, we are using left side formula. If x equal to 0, 1, otherwise p by 1 minus p. If x equal to 1, x equal to 0. If you see binomial theorem, f of x is equal to x to the power of n of p to the power of x multiplied by 1 minus p n to the power of x. If x comma, then the Poisson distribution. See how it look like. F of k comma lambda and PR equal to x equal to k, and finally lambda k multiplied by e power minus lambda k factorial. Seventh topic, last but one, hypothesis testing and statistical significance. If you see null hypothesis, alternative hypothesis. So null hypothesis is nothing but a general statement that there is no relationship between two measured phenomena. It's called Sinner association. Association group mining says that relationship between two measured phenomena or no association among groups. Then alternative hypothesis, be contrary to the null hypothesis in a statistical manner, is doing like that. Alternative hypothesis means by contrary to the null hypothesis. We have a tier 1 errors, tier 2 errors. Tier 1 errors, rejection of a true null hypothesis. With a type 2 error is the non-rejection of a false null hypothesis. So what is meant by interpretation? We are changing or we are converting from one language to another language, that is called interpretation. If you want to understand very easily. Then there we have three concepts like p-value, critical value, significant level, and rejection region. P-value is nothing but suppose we have given to hypothesis. So now see how to give p-value and how to do interpretation. Yes, suppose when p-value greater than alpha, we fail to reject the multi hypothesis. While p minus, p value less than or equal to lambda, we reject the null hypothesis and we can close to the, we have a significant result. Critical value, a point on the scale of the test systematic statistic beyond which we reject the null hypothesis. And from the
So.
Sundar, my voice is audible?
Yeah.
So,
how many slides left on the statistics, sir?
It is there. Yeah.
Yeah, the quite. Yeah, quite.
Yeah, it is there.
So I know you look tired. So is there a way we can catch up next class?
Yes, yeah, sure. So you can stop the recording.
Sure.
And
I'll stop it.
yeah, we'll continue.